Hi, this is Mrs. Rutchling. Welcome to Chapter 5, Ions with More Than One Charge. There are some ions, because of how their electrons are arranged, have more than one possible charge. These are located within the metals, the transition metals primarily, but not all transition metals will have more than one charge. When we write the name, but only the name, it must have a Roman numeral because we could have copper 1 or copper 2. So we must use a Roman numeral to tell which one we have used. And these are the ions that you need to memorize. We have iron, chromium, cobalt, lead, copper, manganese, and tin. And of these, we already know 4 of them from our summer assignment. Those are the ones that are outlined in green. Here is a very complete list that you can refer to. Here is one that's a little easier to read. The ones circled in blue are the ones that you need to memorize. Group 1 has a +1 charge. Group 2 has a +2. Over here we have a pattern. 17 has -1, 16 -2, 15 -3. So it can be helpful to remember zinc and cadmium as +2 because they're right before 13 or +3. Here are some examples of writing the names with the Roman numerals. The formula looks just the same. This happens to be iron 3, and so we put that in parentheses. Iron, Roman numeral 3, chloride. We have copper chloride. What copper is it? It's copper 1, so copper 1 chloride. You will see it written with and without the parentheses, and either way is okay. You might see the Roman numerals written more traditionally. Any variation of that is okay. If we have the formula, we can determine the metal's charge. Since there is no overall charge, the sum of all of the charges has to be 0. We recognize copper can have multiple charges, and we don't know which one is used here, so we put that as an X. And then chloride has a -1 charge. That tells us that X is 1, and so this is copper chloride, copper 1 chloride. With lead, again, we don't know the charge. We know it could be, we know that lead has more than one charge, so we know in this case that it is 2. So we have lead 2 oxide. Lastly, we have iron and sulfide. We don't know iron's charge, so we can make that 2x. 2, because we have 2 of those atoms. We have 3 of the sulfides, and the whole thing is equal to 0. 2x plus 6 negative equals 0, and so x is equal to 3. And so we have iron 3 sulfide. How do we name them? Well, naming is just the same. Name of the cation. If it has a multiple charge, now we add the Roman numeral, and the anion ends in "ide." Pause the video and give these a try. Since I have 2 negative charges, I know that my iron must be +2, so I have iron 2 bromide. Copper chloride, but what copper? Well, there's only 1 negative charge, so it must be copper 1 chloride. Tin is a cation that has multiple charges. I have 2 oxides, so I have a total of -4, so this is tin 4 oxide. Iron, I have 2 of them, and I have 3 of the -2, so if I work this out, each iron is iron 3, and so I have iron 3 oxide. Pause the video and give these a try. Remember to reduce it. I have the 2's. I know it's already iron 2, so I write my formula, FeS, and it's iron 2 sulfide. Using the crossover formula, I get a formula of CaH2, and this is calcium hydride. Notice there's no Roman numeral because calcium is not a metal that has more than one possible charge. Using the crossover method, I get a formula of CuBr2. Now I know copper is +2, And copper is one that has more than one charge, so the name is copper 2 bromide. This underscores the importance of writing the second letter in lowercase. I see that cobalt has more than one charge, and the 2 is given, so I know it's cobalt 2 oxide. Recognizing that lead has multiple charges, I determined that sulfide is -2, and there are 2 of them, so I have a charge of -4. There's only one lead, so it must be +4, so I have lead 4 sulfide. Copper can create multiple charged ions, so I have to look at the -1 of chloride. It tells me that that's copper 1 chloride. If you recall, zinc does not make multiple charges, so there should be no Roman numeral. Pause the video and write the formulas. The name tells me that it's chromium 3, so I use the chromium 3 cation and the iodide anion and get my subscripts. Gives me iron's charge, so I can use the cation iron 3 and oxide and come up with the subscripts. Manganese charge of 2 is given. I write the cation, the sulfur, I cross. When I do that, I don't have the simplest ratio, so I reduce it to MnO. For tin 2 bromide, again, I take the 2, that tells me tin's charge, and then I cross to get the formula SnBr2.